Hello and welcome to Cloud Native Talks. The title of this presentation is What is Cloud Native and Why Should I Care? Presented by Tomasz Tarczyński, Systems Architect at Gigaset. This event will proceed as follows. A short introduction, the main presentation, What is Cloud Native and Why Should I Care? And finally, a QA session. Please save your questions for the QA session at the end. My name is Marcin Kraszewski, and I'll be your host for this event. Our speaker is Tomasz Tarczyński, and we will be supported by Magdalena Ponoska of Cognitive. And now, please welcome our speaker, Tomasz Tarczyński, with his talk, What is Cloud Native and Why Should I Care? But before we get to that, please note the following upcoming events: Cloud Native and Kubernetes Tri-City regular meetup on the 11th of January 2019, Cloud Native and Kubernetes BIAޅYSTOK on the 15th of January 2019, Cloud Native Week Warsaw taking place between the 18th and 22nd of February 2019, Cloud Native Warsaw Conference taking place between the 16th and 17th of May 2019. And for all of the event info related to tonight's meetup, please read the notes posted below the video that will be posted to YouTube.
Okay, thank you, Marcin, for the introduction. I'm Tomasz Tarczyński. I'm a system architect at Gigaset, and I'd like to talk today about Cloud Native. So what it really means. Is it something we should care about? Have you heard more and more about Cloud Native recently? Do you have a clear definition or understanding of what it's really about? I've heard a lot about it in the last 3 years, but what's the essence of it wasn't clear to me at all. But let me start with a short story to explain why am I interested in this. At Gigaset, we built a smart home system that lets our customers monitor the safety of their homes and also program some automated actions. The three main parts of this system, the devices at customers' home, so sensors and programmable actors, for example, a door sensor, a motion sensor, and a smart plug or an IP camera. And on the other end of the system, the front-end applications on customers' smartphones. So a customer can be notified about events detected at home, can see the history of those events, and can program some actions, like turning the lights on when coming home. And then, in the middle, there is the brains of the whole system, the backend that lives in the cloud. All the logic of our system is deployed there. And all the functionality is delivered with code running in this cloud-based backend. And to make our customers happy, we need to meet two critical non-functional requirements for this backend. First is that our system has to be super reliable. So we need to limit any malfunction or unavailability to a minimum. And also make sure that the response times are fast enough. It's because all the functionality that we have is not worth much if the system happens to be not available. Also, waiting for several seconds for an application to respond is a bad user experience. And the second requirement is that we need to deliver new features ultra fast. That means not going through a month-long process to deliver new code, but rather to be able to push it to production within an hour or two. And to achieve these goals, we were working constantly on improving our technology and practices. And I want to tell you just about few of the big and important changes that we've made. So first change is about how we package and run our applications. We used to package the apps into RPM packages and used a process supervisor, systemd, to ensure that they are always up and running. We replace that with Docker containers. That gives us a standard packaging format, so containing all dependencies needed by an application. And the images are immutable, meaning once baked, they never change in the environment. It also helps us ensure environment parity between development, staging, and production. That way, our applications are easier to build, to run, and to manage. Second change is that we moved from a monolithic architecture where all backend functionality was done in a single application to microservices, with each function living in a small dedicated application. That way, they are much easier to develop and deploy, mostly because these microservices are loosely coupled. So there is no longer a need for developer to synchronize with different teams or colleagues before they deliver a change to production. It's enough if they make sure that the changes are backward compatible and they don't break the API contracts between the services. And third important change is about automation. So we made sure that all changes related to the infrastructure and applications are fully automated. They are always defined with code, and that this code is kept in version control. This way, we can have a good record of the whole history of changes. We have the possibility of an easy rollback of any change. And thanks to that, we can actually take more risk, because even if a small change that we deliver results in a failure, we can very quickly take a step back to the last known good state. But there were also some challenges going down this path. First was about the growing number of applications, which became bigger and bigger a trouble for us to manage, even with all the automation we had. We use Puppet as our infrastructure automation tool of choice, and it's great at its job, which is configuration management of all the nodes. But with the number of application instances being near 300, we were actually hitting the limits of that approach. So we wanted to be able to focus on the application. How should it run? What configuration should it get? And also, what resources does it need? But Puppet is mainly host-centric. That means you need to describe how each host should be configured. Then you focus on the operating system level details of your environment. Things like what packages to install, what configuration files to put there, and what processes should run on each host. So we started to look for something that would be a better fit for such a task. something that would let us orchestrate microservices dynamically on a big cluster of machines. So we would no longer worry about the state of individual nodes, but rather manage the state of the whole cluster. So to learn what are the possible solutions to this, I went to a cloud-native conference. I've seen there this cloud-native landscape with tons of useful technologies. I've learned about some tools that can help us manage the microservices dynamically. But I didn't learn what this cloud-native is really about. So then I started to dig into how different people describe and explain it. I found several different definitions and different points of view, and that these definitions are still evolving. But the first question to answer was, why should I actually care? What benefits can we get from this approach? And if it's any good, how can I sell it to my boss? There are a number of case studies available from the companies that adopted cloud-native approach already. Among them are the Financial Times and Zalando. And unicorns like Netflix have used similar methods for years. One such case study is available via Container Solutions in their small book on Cloud Native. It's about the Financial Times, a news organization which is read by over 2 million people daily. So they spent 3 years building a cloud-native platform and migrating the applications. And what results did they get? Their reliability improved a lot. Before that change, they needed to roll back 1 deployment in 5. And after, it's only 1 in 1,000. Next change is the lead time. So how much time do they need to move new code from a commit to running in production? This went down from 4 months to just 15 minutes. So a huge improvement as well. And the frequency of deployments. It went up from deploying to production only 12 times a year to about 2,000 releases per year. That means they can move way faster. And at the same time, they give a super reliable product to their customers. If you like to learn more about their experience, I really recommend a great talk by Sarah Wells from the Financial Times, which was presented at KubeCon 2018. What's very interesting to me there is that while improving reliability and velocity, they also cut their operational costs, but by approximately 80%. And another example is what we did at Gigaset. We've done our migration from a monolith to microservices, and we also saw a great difference in performance of software delivery. Our reliability improved a lot. So a rollback ratio is now 40 times lower. Also, the mean time to recover, MTTR, went down by over 30 times. This means that when a failure happens, we need much less time to restore normal operations. And the next metric is the lead time, showing how fast can we deliver new features to our customers. So how much time do we need from code commit to it being available to customers? It went down by over 200 times. So it's no longer 2 months needed to deliver a change, but only 1 or 2 hours. If you are interested in such measurements, I recommend this year's State of DevOps report. It's based on 5 years of surveying over 30,000 technical professionals. And it shows a big performance gap between the low and high performing organizations. But also, it recommends some strategies, because the authors analyzed what are the common practices among the best performers. And they mention and describe there, among other practices, things like the 5 essential characteristics of cloud computing, and also usage of cloud-native architecture. So they've seen those topics among those that are special for the best performing organizations. And I think it's really worth checking out this report for more details. Okay, so after looking into the case studies, let's summarize what benefits do those organizations see. First is the reliability. So by using cloud-native methods, they can deliver very small increments of work, which makes the risk of a single change much smaller. Also, they split applications into small components, so a failure affects only a small part of functionality and often can be unnoticed by customers. And there is an autonomous system there, managing applications and infrastructure, that reacts to failures of individual components without human intervention required. At the same time, they increase the velocity of delivering features to customers. That's because they have a self-service platform that they use to deploy small increments of work. This way, the deployments can go faster by orders of magnitude. And this is how Netflix sees the relation between those two. So between the rate of change and availability. They say that if you want better availability, you should slow down the changes. And when you increase the rate of change, you may get lower availability. They also asked how to improve both. So how to shift this curve up. And they say it's only possible by a radical change in architecture, technology, and practices. And Netflix did that by completely re-architecting their platform for the cloud. And then the third benefit is in efficiency. It means they put less work into the mundane management of growing infrastructure, because now all routine decisions are made by a platform. And also, infrastructure costs can go down with better utilization of cloud resources. The next question to answer was, how can I implement the cloud-native approach to building and running applications? And among the different methods I found, the 3 most often advised. First is to package your applications into containers that are used as a unit of application deployment, and a lightweight app isolation mechanism and standard control interface for them. That way, you get a great benefit of standardization. It lets you standardize on a single package format, one way to deploy, and one way to control the application. As Google describes it, containers let you transform the data center from being machine-oriented to application-oriented. Second method is that you should have your applications dynamically managed. by an autonomous orchestrator. So a human needs only to describe the desired state of the whole cluster, not dealing with individual machines, and the application lifecycle is taken care of by software. Then a developer gets a self-service logical infrastructure where computers decide which workload goes where. And in case of hardware failures, a platform applies automatic fixes. And the third method is to break down the application into microservices that are small, single-purpose, and decoupled, with well-defined interfaces like REST APIs. You benefit from them being easier to develop and update and cheaper to operate. So each microservice can be owned by a small team, which then can deploy it at will, independently of other teams, and also can scale it independently. Okay, so wrapping this up with some kind of a definition, cloud native seems to be a technological paradigm that prescribes these three methods: container packaged applications, dynamically managed, and microservices architecture. What I found also relevant is the 12-factor applications methodology presented by Heroku in 2011. It describes how to design your applications to run on the cloud platform. And I will highlight just a few of these best practices. Number 2 there is about dependencies, which says that an application should never rely on system-wide packages. And today we can achieve this by just using containers. Number 3 is about configuration. So it should come in the environment and not inside the application artifact. And the number 6 here is processes. So applications should run as stateless processes with no state shared between one request and another. And there are more of these best practices. And here, number 7 about port binding. So application should expose the functionality by responding to requests via network port. And another one, concurrency. So we are scaling out our application by running multiple process instances on multiple machines, and they should share nothing between them. Another one, disposability, which says that applications should be designed to be started and stopped really fast. That's for fast elastic scaling and rapid deployment. It means we should minimize the startup time to something like just a few seconds, and also make a graceful shutdown possible on receiving a sick-term signal. Okay, so let's get back to the definition of cloud native. When I've tried to find how people define it, I most liked what Justin Garrison and Chris Novas said in their book, Cloud Native Infrastructure, which I really recommend. So it's about infrastructure that is hidden behind useful abstractions. So you no longer deal with individual machines, but have an API to control the whole cluster. This infrastructure is managed by software. So there is an autonomous orchestrator which constantly makes sure that the cluster is in the desired state. And applications are designed to be managed by software, not by humans. You can think here about the 12 acts methodology that I've just shown. So instead of producing operational documentation or writing sophisticated scripts to automate our apps, we rather make sure that we have standardized app interfaces. And one more thing. How does this all relate to DevOps? So having those new ideas, should we now abandon DevOps at all and go for those new? Thinking about what is the essence of DevOps, I follow the description proposed by Adam Jacob in his talk, DevOps Kung Fu. He says there that it's a cultural and professional movement, and that it's focused on high velocity. So actually, I would say DevOps has the same focus as cloud native. And the second well-known description is by John Willis. He says that DevOps is about culture, automation, measurement, and sharing. So he describes the practices and areas which the DevOps movement tries to improve. And then when we compare this with cloud native, I would say that cloud native focuses just on the two of the DevOps areas, so on automation and measurements, and also has the same goals as in DevOps, to allow high velocity and great reliability, and also to make scaling our applications, our business easier. But the difference there would be that cloud native, at least for me, is just about technology. So it proposes solutions to improve these two areas, and also an opinionated approach to building a platform. And I would also argue that cloud native actually requires DevOps. So I mean that you cannot be successful with this kind of architecture without working also on the culture and sharing in the organization. And one more thing, being already near to the end of my talk. So do you think this is all something very new? Is it only possible for the last 2 years or so to manage applications this way? So let me show you just a little bit of history. We have these 3 methods of cloud native that I talked about. So first is containers. And you can recall that already in 2006, Google started the work on the C groups technology in Linux kernel. And then the userland tooling was available already 2008 with LXC. And in 2013, the Docker project started. The second method, so orchestration, here already in early 2000s, Google orchestrated their workloads with their internal tool called Borg. Then in 2009, the Mesos project started, which was inspired by Google's Borg. And a year later, Twitter started using Mesos. And in 2014, Kubernetes was first released. And the third method, which is about microservices and cloud architectures. So 2006, AWS launched with S3 and EC2. And the same year, their CTO, Werner Vogels, described how they architect the microservices platform with his famous mantra, "You built it, you run it," meaning that each microservice is fully owned by a small team. And then 2010 is a year when Amazon moved all its retail to AWS, and also Netflix moved the streaming business to the cloud. And also they started the Netflix OSS, where they share most of their cloud technology as open source. So as you can see, the cloud native methods were already used and available for over a decade. And what I mean is that the ideas I talked about actually aren't new at all. But what have changed just recently is that the access to the cloud native methods is now democratized with all those great open source projects that are easy to use and that allow even a very small team to get the same robust technology that was earlier available only to the biggest unicorns like Google or Amazon. And also, we've got the Cloud Native Computing Foundation that can be a guide for us to how mature these projects are and what can we use to help us solving our infrastructure problems. Okay, so that's all that I have for you for today. Thank you very much for listening. And I would like to get back to Marcin and check if we have any questions.
Sure, Tomasz. Well, I'm here. Thank you very much for getting to the QA. We got a couple questions from our YouTube audience. The first question is, what's the difference between container solutions of individual vendors and which solution is better? All right, let's try that again. We're going to be doing the QA session right now. We're going to be going through the questions that have been asked by our YouTube listeners and watchers, viewers. And Tomasz, if you're ready for the first questions, let me know.
Yes, I'm ready.
Okay, so the first question is, what's the difference between container solutions of individual vendors and which solution is better?
Okay, thank you for that's a great question because actually many of those. So what kind of container runtime can we use? And I would say, just personally, I still use Docker. It's something that started quite early, is around for already a few years. And yeah, for me, that's the choice. But other things are already getting mature. So things like the containerd projects, they are probably also good.
Okay, good. The next question is, how is the current replication of containers carried out?
Current replication of containers. Okay, so speaking about the platform that we've built at Gigaset, actually, we are still going through this path to have all the three characteristics cloud native architecture. Our application is already split to microservices and run as containers, but we still are migrating it from replicating them using Puppet to using Kubernetes as the orchestrator for those. So in our case, that's our current status. And for anyone else, there are actually many possible solutions. You can be using things like Mesos, or maybe Docker Swarm, or Nomad from HashiCorp. So there are many possibilities there. And for example, some of the teams describing what they've done in the case studies, like the Financial Times, they had even tried 2 or 3 different solutions and then compared methods before they decided to go for Kubernetes. So it's always you need to find what works best for you. But for sure, Kubernetes today has the biggest user base. So that's why actually it might be a good choice.
Okay. And what are the most common mistakes during replication, and how can you prevent them?
Okay, common mistakes during replication. Yeah, there are some for sure. I would say each time when you don't make those small microservices really stateless, it can result in some problems. So I would say the best method would be to go and follow those 12-factor apps methodology, because it gives quite good prescribed methods of how to avoid problems that you can see, for example, when applications are, for example, not ready to be running 2 different versions of the same application simultaneously. So then you need, again, to make your applications proof to such case. So to be like backward compatible between different versions.
Okay, and here's another one. How has the recently discovered bug in Kubernetes affected the trust of customers?
From my point of view, it actually, I would say, wouldn't affect it very, very heavily, as it was actually probably the first such big issue found in Kubernetes. And still, customers that don't expose the API are still quite safe. Like if it's available only internally. But
okay, and how is Kubernetes licensed?
Okay, so here we've got it totally open source. So we can just have all the components needed from the upstream projects, install it ourselves, and that's it. So it's simple here, but also there are quite many options available to get a managed cluster, so managed by someone else to help you to get faster to having a running platform. And then there the different vendors are licensing their products that are built on top of Kubernetes. So you've got both worlds, like the open source product and then the products built on top of that.
Okay. Is replication done by reading logs from example for a native database And how will this affect the replicated container if one log is omitted?
So the Kubernetes platform itself doesn't actually have any opinion here. That's so this kind of replication, when it comes to data to the state in your application, is actually left for the user to cover it. And then, depending on, do you use a typical transactional database or some other kind of database, you then make actually different compromises between the consistency of your data and the speed of operation. So it's it's left for the user to decide. Okay.
Tomasz, is it possible to mix Linux host and Windows host without a backwards without getting mixed up in one big node?
I'm not sure if I get this question right.
Sure, it might have been. We might have had a little issue with translating the original there. Just a moment.
Okay. Yeah. So maybe if it's about the Windows host in Kubernetes, I'm not familiar with this at all. So haven't tried and don't know. I'm only aware that there is some work going on to giving better Windows support. That's that's all that I know.
And someone is asking, Tomasz, is it safe? Is Kubernetes safe, or even referring to the previous question? But the question is it safe?
Okay. So from my perspective, I would say it's a question of what kind of platform do you want to have and on what kind of platform you want to run your applications. And then probably, I would say for most use cases, it is already something safe to use. And I mean stable enough, mature enough to depend your application, your workloads on. But probably, I would imagine that there are still some sectors, some kind of businesses that are not very willing to go very fast to new technologies and new architectures like that. But from my perspective, yeah, it's good.
And how, if let's say you're an engineer, how would you start using serverless? Do you write code? Do you create a flow? What's the process that someone should get started with serverless as an engineer?
So my idea here is basically to be starting with something really, really small. I haven't worked with that, but what we've done in Gigaset was actually introducing serverless as for a very small part of functionality of our product. So things like integrations with third-party services, and then if it was a functionality for just not a very big amount of code, it was a good bet for us to try serverless there, and it actually works fine for us there.
Okay, great. Well, Tomasz, it looks like I'm not seeing any other questions coming up. It looks like we're going to have to sort of wind down the event here because we just don't have any further questions. Tomasz, is there anything you want to say as we come toward the end here?
Yeah, I would like to say thank you to all the listeners. It was the first attempt for me doing webcast, and I really liked the experience, and I hope you enjoyed this. So thank you very much.
Thank you, Tomasz, for that presentation. And as we move forward here, we want to tell you, first of all, thank you very much for taking part in this webinar. And we also want to make sure that we tell you about the upcoming events. On the 11th of January 2019, we got Cloud Native and Kubernetes Tri-City regular meetup. The 15th of January 2019, we have the Cloud Native and Kubernetes BIAۯYSTOK regular meetup. The 18th through the 22nd of February 2019, we have Cloud Native Week Warsaw. And the 16th through the 17th of May 2019, we welcome you to Cloud Native Warsaw Conference. Thanks for listening, and we hope to bring you more webinars in the future.